and write formulas for binary ionic compounds with multiple valences. So you're going to have some compounds that are ionic, they have a metal and nonmetal, where the metal can be a multivalent metal. What that means is the metal can form more than one type of charge. So let's go take a look at our periodic table quickly. If you look at sodium over here, sodium can only form one charge, +1. We call it a monovalent metal. Mono meaning one. It only has one possible valence, one possible charge. Let's go take a look at some elements in groups 3 to 12. These are transition metals. Many of the elements, not all of them, but many, you'll notice have more than one possible charge. Iron, for example, has +3 or +2. Cobalt, +3 or +2. Palladium, +4 or +2. So they have more than one possible type of charge. So whenever you have a multivalent element in a compound, you need to somehow indicate, well, which multivalent element version you have. Do you have the iron +3 in there or the iron +2 in there? You wouldn't need to do that for something like sodium or potassium or calcium because they only have one possible charge. It would be kind of like if you had 3 students with the same name in the class. So you had 3 Simrans in a class. You couldn't just yell out Simran because they'd be confused. Who are you calling? You'd have to specify with a last name maybe. Simran A, B, C. So I need to tell you, do I have iron 3 or 2 in my compound if I have a multivalent element? So you don't have to memorize the charges of these multivalent elements, but you do have to recognize that you have a multivalent element in a compound. So there's 2 different systems to represent multivalent elements. There's the Stock system, and then there's our Latin classical system. In this video, we're going to focus on the Stock system. In the next video, we're going to focus on the Latin classical system. So I'm going to start off by showing you how to write a formula for a situation where you have a multivalent element. So let's just go below. Let's say you were given the compound iron 3 chloride. The steps are the same as for the regular binary ionics. In fact, this should be a bit easier. The Stock system uses Roman numerals to tell you which version of the multivalent element you have. So here I have the Roman numeral 3. This tells me I have iron 3. So you simply write down the symbol of the ion, iron +3. The metal is going to be positive. You're always going to see the positive metal, and the non-metal is going to be negative. Chloride is -1 because it's in group 17. Do your crisscross or your charge balancing, whichever one you prefer. And you get FeCl3. This means you have 1 iron ion and 3 chloride ions. If you did charge balancing, it would make sense. Fe +3, Cl -1. You want the overall charge to be 0, so you need to add another Cl -1. That gives you an overall charge of +1. We're not quite there yet. Add one more, and now we're at an overall charge of 0. So we have 1 iron 3+ and 3 chloride ions in this compound. The small number, again, is called a subscript. It indicates the number of ions you have in that compound. For every 1 iron ion, there's 3 chloride ions. So it's called a subscript, a small number. Sub meaning below. So to make a formula for a binary ionic compound with a multivalent element, you follow the same rules. The only difference is you're told the charge of the metal. You don't have to go look for it in your periodic table. You're told it's iron 3 in this case. You do your crisscross or your charge balancing. If you had to reduce, you would also reduce. So now what we're going to do is we're going to take a look at how to name a compound that has a multivalent metal inside of it. It's very similar to naming a binary ionic compound with a monovalent element. The difference is you have to figure out, well, which version of the metal do you have, which charge, so you can indicate it. So let's say I had FeCl2. To figure out which iron you have, you need to do the reverse crisscross. The numbers at the bottom that you see here, they got there because of crisscross. You have to find out what the original charges were. So you circle the subscripts, and notice I added the 1 there because we know there's a 1. And reverse the crisscross. Bring the 2 back to the iron here. Bring the 1 back to the chloride here. Fe2. And remember that it's a metal. The metals are going to be positive. Plus Cl minus 1. So this tells us we have iron 2 here. So our compound is iron 2, Roman numerals, chloride. If you don't remember your Roman numerals, go back and study them. It's no big deal. If you don't remember them, you can simply review them. Sometimes you haven't seen them in a long time. Alternatively, you could have done a charge balancing method. You have 1 iron and 2 chlorides. Draw that out. Iron, you don't know the charge, so put a question mark. But draw your chlorides. You know your chloride charges. That's from your periodic table. You have 2 of them. Overall, my charge is -2 right now. I need to make this overall 0. So the only way for the overall charge to be 0 based on the formula of the compound is if this iron is +2. If it was +3, you'd have +3 minus 2, that's +1. That's not 0 overall. So that's the only way to get a charge of 0 overall if your iron is +2. We'll do one more example. So let's say you had CuO, and you had to name this. Let's do a reverse crisscross. Put our 1s there. Bring the 1 from up here over here, and the 1 from down here over here. And so we get Cu plus 1, O minus 1. The multivalent metal is always a mystery to us. We don't know what the charge is until we somehow figure it out by doing a reverse crisscross. And so most students would say, well, this is copper 1. Now, this is actually not copper 1. Here's the problem. You'll notice your oxygen has a charge of -1 here. But you know oxygen should have a charge of -2 based on your periodic table. It's in group 16. It has 6 valence electrons. It gains 2 instead of losing 6. So you probably guessed it already. This compound was probably reduced. We have to do everything in rewind here. We reverse crisscross. Now we have to reverse reduce. So we have to multiply. So if our oxygen was -2 and now it's -1, it means we divided by 2. So we have to multiply everything by 2 because everything was divided by 2. And so when you do that, you multiply the -1 by 2, the +1 by 2. This becomes Cu plus 2, O minus 2. Now we have the correct charge. And so that means our copper was actually copper 2. Oxide, not copper 1. If you did a charge balancing, you would have seen it right away. You have O minus 2. Based on our formula, we have 1 O. So again, our formula was CuO. You have 1 O, so I write that down as -2. And then Cu question mark. If you go to your periodic table, you take a look at Cu. You have 2 choices, +1 or +2. So which one would make the overall charge of the compound 0? Well, it would be the +2. If you put +1, the overall charge of the compound would be -1. So this has to be +2, and that gives us copper 2 oxide. In the next video, we're going to take a look at how to write formulas and name multivalents using the classical system.